Have you ever really thought about math as a language? Because it is. It's this universal language that honestly builds everything around us. But just like any language, it's got this hidden grammar, a set of rules that stops it from becoming total chaos. So today, we're going to master that grammar. All right, take a look at this. Seems pretty simple, right? But here's the thing. Depending on how you try to solve it, you could get a bunch of different answers. But in the world of math, there is only one right answer. So you think you know what it is? Stick with me, and I promise you'll be able to solve this without even thinking about it. Imagine trying to read a sentence with zero grammar or punctuation. It's just a jumble of words, right? Total nonsense. Well, that's exactly what math would be without its rules. That equation we just looked at, it could mean anything. These rules are what bring order to all that chaos. They make sure an equation means the exact same thing whether you're in Tokyo or Toronto. Okay, so let's jump in with rule number 1. When you're only dealing with adding and subtracting, things are super straightforward. There's no complicated hierarchy to worry about. You just solve from left to right. Simple as that, just like you're reading a book. Let's actually walk through one. So we've got 55 minus 14 plus 31. Following our rule, we just start on the left. 55 minus 14, that's 41. Then we take that 41 and add 31. And boom, our answer is 72. See? Easy. Just moving left to right. So what about the other pair, multiplication and division? Well, it's the exact same idea. They're kind of on the same level of importance. So when it's only them in an equation, guess what? You solve them from left to right. Okay, check this out. 48 divided by 4 times 3. Now, you don't want to jump ahead to the multiplication. Nope, we start on the left. 48 divided by 4 is 12. Then, and only then, do we multiply that 12 by 3, which gives us 36. That left to right rule is holding strong. All right, so what happens when you mix it all up, when you throw everything into the pot? Now we've got subtraction, multiplication, and addition all in one problem. So how do you tackle this? Do you still just go left to right? This is where the real grammar of math starts to show up. And that brings us to the next really, really important rule, the hierarchy of operations. Think of it like this. Multiplication and division, they're the VIPs. They get to go first, way before addition and subtraction, and it doesn't matter where they are in the line. So looking back at our problem, your first instinct might be to just do 26 minus 4. But wait, we have to follow the hierarchy. We got to scan for any multiplication or division, and there it is, 4 times 5. We solve that first, which gives us 20. So now our equation is much simpler, 26 minus 20 plus 7. And from here, we're back to our simple left to right rule. 26 minus 20 is 6, and 6 plus 7 is 13. Done. But what if you want to break the rules? This is where it gets really interesting. What if you're the one writing the equation and you need that addition to happen first? How do you override that hierarchy? Well, math gives you a superpower for that, and they're called parentheses. Just look at the difference this makes. On the left, that's the problem we solved before, which we know is 72. But on the right, just by adding those little parentheses around 14 plus 31, we have completely changed the game. Those parentheses force us to solve that part first, which is 45. And then 55 minus 45 is 10. A totally different answer, all because of 2 simple symbols. It's wild. Let's try another one with these in the mix. Here we've got subtraction, division, and those super powerful parentheses. And the rule is absolute. Parentheses always win. They come first. So 12 plus 8 is 20. Now our problem looks like this. 16 minus 20 divided by 4. Okay, now what? We follow the hierarchy. Division comes before subtraction. So 20 divided by 4 is 5. And finally, we're left with 16 minus 5, which is 11. And there you have it. This is the whole system, the entire grammar of arithmetic, all right here. Let's call it the master rule. Step 1, parentheses, always. Step 2, handle all the multiplication and division. Just go from left to right. And finally, step 3, clean up all the addition and subtraction. Again, moving left to right. That's it. That's the secret code to solving these things. Okay, you remember that big challenge from the very beginning? Well, now that we have the master rule, we are ready. We are equipped. Let's go defeat that problem step by step. All right, let's put our rules into action. Step 1, parentheses.
4 plus 8 is 12, so the equation now reads 32 minus 3 times 12 divided by 2. Okay, step 2, multiplication and division left to right. First thing we see is 3 times 12, that's 36. Now we have 36 divided by 2, which is 18. And look at that. All we have left is step 3, 32 minus 18. And the one single correct answer is 14. We did it. Fantastic.
All right, you're pretty much a pro at this now. So let's try a different kind of problem. This one isn't just about following the rules. It's about using those rules strategically. It's a classic little mathematician's puzzle. Ready? So to crack this puzzle, there's one key piece of strategy you need to know. When you're dividing, if you want the biggest possible result, you need to divide by the smallest possible number. Makes sense, right? And if you want the smallest result, you do the opposite. You divide by the biggest number you can.
Okay, so here's the challenge. We're using the numbers 1, 5, and 6 to get the largest and smallest possible results from this equation. So, for the largest result, we need the smallest divisor. We'll put 1 and 5 inside the parentheses to get 5. 30 divided by 5 is 6, and then we add our leftover number, which is 6, to get 12. Not bad. Now for the smallest result, we need the biggest divisor. So we'll put 6 and 5 in the parentheses to get 30. 30 divided by 30 is just 1, and we add our last number, 1, to get a final result of 2.
So, why does any of this matter? Why did we spend all this time on what might feel like simple arithmetic? Well, because what you've just learned isn't just a party trick. The order of operations is the absolute foundation, the bedrock that all of higher math is built on. From algebra to calculus and beyond, this grammar is non-negotiable. You know, as you go further in math, you'll run into even more advanced grammar, like the commutative, associative, and distributive properties. You can think of these as like the complex sentences of the language. But every single one of them builds on the foundational rules, the order of operations that you've totally mastered today. So we'll leave you with this thought. We've just uncovered a hidden set of rules that brings order to the chaos of numbers. And it kind of makes you wonder, doesn't it? What other grammars are out there, quietly organizing everything from music to biology to the traffic in our cities? What other hidden rules are just waiting for us to discover?